Have you ever gazed up at the night sky and wondered if we're alone in the universe? This seemingly simple question has captivated our collective imaginations for centuries, driving us to delve deeper into the mysteries of the cosmos. The possibility of life beyond Earth is a fundamental query that has shaped our understanding of our place in the universe. Historically, perspectives on extraterrestrial life have ranged from the philosophical to the scientific. Ancient civilizations often interpreted celestial bodies as divine entities, while the Enlightenment era saw a shift towards a more scientific approach, speculating on the existence of life on other planets. Fast forward to the 21st century, the question has become more pertinent than ever. With the advancement of technology, we're not just speculating anymore, we're actively searching. The answer to this question lies in the vastness of space, on distant worlds known as exoplanets. But what makes a planet habitable, capable of supporting life as we know it? Well, it's a fascinating blend of just the right conditions. Consider the concept of the Goldilocks zone, a term that might evoke images of a certain fairy tale, but in the realm of astrophysics it refers to a region around a star where conditions are just right. Not too hot, not too cold, for liquid water to exist. This zone, also known as the habitable zone, is crucial because water, as far we know, is the elixir of life. Now, being in the Goldilocks zone doesn't automatically render a planet habitable. There are other factors at play. For instance, the size of the planet matters. A planet too small, like Mars, doesn't have enough gravity to hold on to a substantial atmosphere. On the other hand, a planet too large, like Jupiter, tends to be a gas giant, not solid ground where life as we comprehend it could thrive. Then there's the matter of a planet's composition. A rocky planet like Earth with a molten core generates a magnetic field that protects the atmosphere from being stripped away by solar winds. On the flip side, a planet made mostly of gas or ice wouldn't provide the stable surface necessary for life to gain a foothold. Lastly, a planet's atmosphere plays a significant role in its habitability. A thick atmosphere can trap heat and maintain a stable, warm climate, much like a cozy blanket on a chilly night. Moreover, the atmosphere's chemical composition, particularly the presence of oxygen, is vital as it's a telltale sign of life. So you see, finding a planet with the perfect balance of these conditions is a complex task. It's not just about finding an exoplanet, it's about finding the right exoplanet with the right size, right composition, right atmosphere, and in the right location. Thus, finding a habitable exoplanet is akin to finding a cosmic needle in a galactic haystack. Scientists have developed ingenious methods to detect these distant worlds. The search for exoplanets, those celestial bodies that orbit stars beyond our own sun, is a complex and fascinating endeavor. Today we'll delve into two primary techniques that have led to the discovery of these intriguing worlds: the transit method and the radial velocity method. Picture this. You're gazing out into the night sky, observing a distant star. If an exoplanet were to cross between your line of sight and that star, the star's brightness would dip ever so slightly. This is what we call the transit method. It's like a cosmic game of hide and seek, where the exoplanet reveals itself by momentarily dimming the star's light. It's an event that lasts for only a few hours, but it's enough for our ground-based and space telescopes to detect. Now let's talk about the radial velocity method. This is a bit more complicated, but equally fascinating. You see, as an exoplanet orbits its star, it doesn't just go around in a silent dance. The planet's gravity tugs on the star, causing it to wobble. This wobble changes the color of the star's light ever so slightly, shifting between blue and red as the star moves towards and away from us. This shift, known as a Doppler shift, can be detected and measured, revealing the presence of an exoplanet. These methods, while complex, have proven incredibly effective. They've allowed us to discover thousands of exoplanets, each unique and distinct, circling distant stars. From gas giants larger than Jupiter to rocky worlds that could be our Earth's twin, these discoveries have expanded our understanding of the universe and our place within it. The search for exoplanets is more than just a quest for knowledge. It's a journey of discovery, a testament to our curiosity and our drive to explore the unexplored. Even though these planets are light years away, Their discovery brings us one step closer to answering our initial question. And so we continue to gaze out into the cosmos, eager to uncover its secrets and hopeful that we might, one day, find a world like our own. Among the thousands of exoplanets discovered, a few stand out as particularly promising for the possibility of life. Let's start with Proxima Centauri b. This one's right next door, cosmically speaking. It orbits the closest star to our Sun, Proxima Centauri. Despite being a tad closer to its star than we are to ours, it resides within the habitable zone, where temperatures are just right for liquid water to exist, a key ingredient for life as we know it. Next, we have TRAPPIST-1e, one of 7 Earth-sized planets orbiting the star TRAPPIST-1. This is a fascinating system, with all 7 planets tightly packed in a space smaller than Mercury's orbit around our Sun. But TRAPPIST-1e is special. It's right in the middle of the star's habitable zone, and it's thought to have a compact atmosphere, which could be capable of supporting life. Then there's Kepler-442b. This exoplanet is about a third larger than Earth, and orbits a star cooler and smaller than our Sun. But here's the kicker. It receives about 2/3 the amount of light that Earth gets, placing it firmly within the habitable zone. Its year, the time it takes to orbit its star, is a mere 112 Earth days. And let's not forget Ross 128b. This planet, similar in size to Earth, orbits a quiet star, which means less harmful radiation for any potential life. It receives about the same amount of heat from its star as we do from ours, making it a promising candidate for life. These are just a few of the many exoplanets discovered, each with its unique characteristics and potential for harboring life. They're all at vast distances from us, but they're not beyond our reach. We can study them, learn from them, and maybe, just maybe, one of these distant worlds could be the key to answering that age-old question. Are we alone in the universe? These worlds, distant yet within reach of our telescopes, represent our best hope of finding life beyond Earth. With every new exoplanet discovered, we inch closer to answering the age-old question of whether we are alone in the universe. The future of exoplanet research holds a great deal of promise. As our technology advances, so too does our ability to peer further into the distant cosmos. There are exciting missions on the horizon. The James Webb Space Telescope, which recently launched, is expected to revolutionize our understanding of exoplanets. It is designed to capture light from the furthest reaches of the universe, allowing us to study the atmospheres of distant worlds in unprecedented detail. In addition, advancements in artificial intelligence and machine learning are poised to accelerate the rate of exoplanet discovery. These technologies can sift through vast amounts of data and identify potential exoplanets that might otherwise go unnoticed. As we continue to explore the cosmos, who knows what we might discover? Perhaps one day we might even find that we are not alone.